Hello guys, I hope you're doing well. My name is Sid, and today we are going to be doing another Golang tutorial. We're back to building some Golang fun stuff, and we'll be building a modern real-time web app in Go. We're going to use WebSockets, and we're going to use HTMX, which is a really cool library for doing sort of DOM updates and HTML pages, but in a different way than most common or modern web application frameworks do these days. And today we're going to be using it to build a simple little hardware monitor that shows us what's going on our machine. So as you can see, I've run our little test program here. So let's see what it actually looks like. If I go to the browser, this is what we're going to be building today. We're going to be building SIG's hardware monitor. And as you can see, it shows you a bunch of information about the device. It had a timestamp here. You can see it's actually pushing updates every 3 seconds. It's getting a new update from our server. It's pushing this over WebSockets and it's telling us things about our device, for example, about how much memory we're using. All my CPU cores over here were churning away, and you can see this is actually updating. So if I open a program, let's see, we can open DaVinci Resolve, for example, which is something I use to edit these videos, and you can see my memory just shot up by about 2.5% opening DaVinci Resolve. If I go in and close it again, we should see that memory drop again. There we go, it dropped back down. So this is what we're going to be building. And we maybe won't spend the whole video making it look quite as nice as this. The source code to this final thing will be available on GitHub in the pinned comment below, as always. But we're going to be building the foundation of how this works, and then you can go ahead and make it look the way you want it to look in your own time. So let's exit out of this and close this. And let's have a look at what we're going to be using. So HTMX, I mentioned it. We won't go through in great detail how HTMX works. We're just going to get using it, basically. But as you can see, HTMX is a library that allows you to send DOM updates to the browser not just by sending JSON and having web applications kind of transpile the JSON and work of it into updates, but by actually sending real HTML and telling the DOM to replace certain parts of what's loaded on the website with the HTML that we're sending. And you can do this over WebSockets, which I think makes for a really cool use case for the thing that we're building today, where you basically send HTML over WebSockets saying, these different parts of the website you should update with what I'm sending you now, this new HTML. So it's kind of like server-side rendering or server-side events, and you just send raw HTML out to be rendered on the front end. So let's have a look at how we're going to do this. I've prepared a little example to get us started. So here's our trusty new Vim editor. And this example, let's just walk through it real quick. What it has is it has a directory called HTMX, which has just one HTML file. We'll come back to it in a second. But first we need some data to show it, right? So in this case, we're building a hardware monitor. Hardware monitor, I just thought it was a fun little project to build. It has a bit of data, right, coming from the machine. And so to do that, we use the Go PSUtil library. The Go PSUtil library is a simple library. And as you can see, it has some different methods. It has like information about virtual memory, about the host, about the CPU, and about the disk. And so what I've done is I've created 3 helper functions inside this internal package called hardware. And what they do is you have a get system section, a get CPU section, and a get disk section. And they call on Go PSUtil to get some information. And then for now, they just return a string, basically. So here they just turn a string that we can print out. And if we look at our main function, what we have here is we just have a function main, and then we have a Go routine. If you haven't checked out my video on concurrency in Go, I'll put a card to it in the top, but go check out that video if you don't know what a Go routine is. But what this basically does is it will spin up a thread, and inside that thread, it will just forever run this loop here. And if you look at this loop, all we're doing is we're calling get system section, get disk section, get CPU section, and then we're printing them out, and then we're sleeping for 3 seconds. And then because we don't want our application to exit, we're just sleeping the main thread. So we can try and run this and see what it looks like. So if we do go run command main.go, and you can see we have a really simple monitor here that sort of works, right? It's printing some information about my system, and it's printing it every 3 seconds. And we could say, "Cool, we've built a system monitor in Go," but we want to build a web page rather than this. So let's get right into it. let's have a look. So what we're going to be using to build this web page is, like I said, we're going to be building it using WebSockets and HTMX. So for the WebSockets, there are lots of different WebSocket implementations in Go. I think a really popular one is called Gorilla, but I actually went for one that's called Go WebSocket by Ensure.io. And the reason I went for it is it's minimal, it's idiomatic. This is a very simple implementation of a WebSocket. I think it's a great little library, but it's not maybe the most feature-rich or complicated. I'm not sure. But it definitely was good enough for this use case. So we're only using this to actually handle our WebSocket connection. And then, like I said, we're going to be using HTMX, which we're just going to pull in through a CDN. So we've got lots to get through. So let's get started. So the first thing we can do is we obviously need a web server, right? And as you know, if you've watched some of my other videos or generally on Golang, Go has a great web server implementation that ships with Go in the Met HTTP package. Let's go ahead and pull that in. And then to make our life easier, let's start by defining a struct. So we're going to have a server struct. And this struct will have a bunch of different things. But one thing that we want is we want a way of sending messages to people who are connected to our system, right? So we're going to call those people subscribers, and we're going to have a message buffer, which is the number of messages that we can send be subscribers at any given time. We'll come back to this in detail in a second. But for the actual HTTP server, we also need an HTTP server. And the HTTP package has a mutex server, which allows you to do routing and do HTTP request handling quite easily, called HTTP serve mocks. So they made use of that. So we're just going to store a variable called mocks, and we're going to say it's of type HTTP serve mocks. So this will allow us to actually spin up a web server. And the other thing I mentioned is we should have some subscribers. So subscribers will basically, actually, I'm getting ahead of myself. Before we do that, let's just get the web server up and running. So let's go ahead and create a new function that will create a new server. And this is basically what it will look like for now. And all it will do is it will have this buffer of size 10. And then the next thing we're going to do is we are going to set up I'm not actually not that good. This going to do a little bit more. So we're going to call that S, and then we'll say it's going to add a entry point for the web server to handle. And what we're going to do is we are going to pass it a directory to serve static files from. So let me just explain what we're doing here. So a couple of things what we're doing here, but essentially we are setting up a new handler for a route on our server. The route is the root, right? So basically hitting the root of what our server is hosting. And then we are passing it a file server. So this is a file server handler, basically saying that rather than a function, we're going to pass you a file server handler. And that file server, what it will do is it will serve the static files that are available inside this location. So we've given it the .htmx location. And so it should serve the static files in there. Since we have an index.html file, we can assume that that's what it's going to serve for us. If we go ahead and return as, let's see why it's complaining here. Why is it complaining? Cannot use, right, sorry. It needs to be just handle, not a function. We're just passing it a handle. This is a handle. So what does she do if we run our server? And we should be able to run our server down here. So rather than just sleeping now, we can get rid of the sleep. Where is she going to run the server? And the way we do that is we call listen@serve. I'm not going to use TLS for this. And the server that we pass in, we're actually going to instantiate first. So we're going to say server equals new server. This is the function we just created. And then we're going to pass in that server mocks that we just created. We pass a reference to it. So we're going to say add server mocks, right? And then we can do the usual and say if error, yeah, exactly, would print it out. And we can even go as far as saying, if this error out, that's bad, so let's exit that. Okay, so this is our program so far. Let's go ahead and clear this. And if we run it again, let's see what happens. So it's still printing stuff out, but you can see it's still going. So let's open up a browser and see if we can actually navigate to 8080. And we'll go ahead and refresh this. There we go. So it's now showing 6 hardware monitor loading data. Where is this coming from? You might wonder. That's weird. Where is that coming from? Well, let's look at our index.html file. So I've prepared this little index.html file. And all it does is it has a title and it has some preliminary divs for us to use. And you can see one of them is update timestamp, which has a loading data at the moment. And it has some monitor data and 3 different divs. And this is where we're going to be populating some of our data coming from the machine. And you might say, well, where's HTMX going to this? And the answer is it doesn't come into it quite yet because we haven't actually loaded HTMX yet. So we can go ahead and add HTMX. And one of the ways you do that is there's different ways you can either post it yourself. But HTMX actually really conveniently provide a CDN where you can just pull it in. So if I add some code down here, you can see this is a script tag that pulls in HTMX. And then another thing we want, because we are using WebSockets, HTMX comes with an extension called HTMX WebSockets, which we pull in as well. So another script tag at the bottom here. And you can see we're pulling in the extension ws.js, which is part of HTMX. So we can go ahead and save this file. And now if I go and refresh, you see there isn't really any difference, right? Because we've loaded HTMX, but it doesn't actually do anything. So let's start doing something with it. Now, what do we want to do? We want to implement, like I said, a WebSocket server. Right now we've got an HTTP server, which is great. You know, we've got an HTTP server that's serving static content. Cool. But we want to get started and actually creating a WebSocket server. So how do we do that? Well, like I said, first of all, let's go ahead and cancel all this. This is running in the background. So what we need a couple of things. We want to keep track of subscribers, right? Subscribers are clients, so to speak. Basically, people who are listening to our hardware monitor. So let's define a type subscriber. And for these subscribers, we want a channel that we can send messages on for the subscriber. Again, if you haven't watched my concurrency and Golang video, if you don't know what a channel is, go ahead and watch that video, and then we can come back to this one after. And so now that we have a subscriber struct, when we create the server, we want to have a way of keeping track of all our subscribers. So what we're going to do is we're going to create a map, like so. And that map is going to be a pointer subscriber, and we're just going to store a struct, an anonymous struct there. Subscriber. Typing is very difficult today. It's unknown. Why is it unknown? No, it shouldn't be. All right, we'll come back to that in a second. And so what we want here basically is we want that's an unknown. Yeah. Subscribers and struct literal. All right, sorry. We obviously need to define it up here first. I'm getting ahead of myself and I'm putting things in the wrong place. I'm like a fool. So we want the type of server to have a field, which is a map of subscriber, and then to a amount of the struct, like so. And these will be our subscribers. Yes. Get rid of that. And now that we have that field, we can go down here and we can actually instantiate that map. There we go. That was easier. And now what this will do is when we create the server, we will create a map of subscriber pointers for any subscribers that may be subscribing to our service. And each subscriber in turn has a channel that we need to create when the time comes. So what more do we need? We need a handler function that we can pass to our HTTP server, which we'll put onto the server struct. And we'll call this that's called the subscribe handler. And what this will take is it will take a HTTP response writer, like so, and it will take a request. So have a look. HTTP request. And sorry, GitHub Copilot just got really excited and generated a bunch of stuff that I didn't want. I'm not very sure how I feel about Copilot. I'm kind of demoing it out to see if it's useful. And it's useful sometimes, but it does actually annoy me quite a lot. And what we'll do here is we'll just have a empty function for now where we will say that we'll handle adding a new subscriber. So, and we'll pass in some parameters. We'll create this function in a second. And if that doesn't work, and we'll print out an error and then we'll return. Okay, so now we need to implement the subscribe function, which, as you can see, is also going to be a function on the server. So let's go ahead and implement subscribe. And so what we really want to do, right? Because I'm basically doing some different things here, but what I want to do is I want to be able to create a WebSocket connection and keep track of it and be able to send messages to it. So let's have a look at how we can do that. So I'm going to, just like above, where we have the, let's see what Copilot is making a bunch of stuff up. No, thank you. We're going to do it ourselves. So this will return an error if something goes wrong. And what we're going to do is we are going to use the WebSocket.library, which one I showed you earlier. And we are going to try to create this WebSocket connection. So how do we do that? Well, a couple of things. First things first, we need to create a subscriber struct, right? So we'll say subscriber equals subscriber, like so. And just to get started, we will create the channel, instantiate a channel, right? And you can see we give it a size of our buffer size so that only 10 messages can be the channel at any given time, because we don't want to overload the channel. We don't want to give it them unlimited ability to flood up server. And then we'll come back to this one in a second. But let's just create a stub method here where we say we're going to have a message call or a function called add subscriber, which we'll get to in a second. And what we then want to do, like I said, is we want to instantiate a WebSocket connection. The way we do that is by calling WebSocket.accept. If something goes wrong, sure, we'll return an error. And WebSocket accept will basically accept a WebSocket connection on the HTTP request and using the response writer that's provided, so using these parameters. And that will allow us to connect to this endpoint. And we'll define the endpoint when we actually hook up this handler, subscribe handler up here, to our server, right? So bear with me. I know we're doing a lot of things here. And I'm just going to defer connection will close now. Make sure we close the connection properly. The other thing we want to do is we want to call the close read function, which is an implementation of the IO closer for this subscription or for this context and this connection. And now what we want to do, if you think about it, what we're really trying to achieve here is we want to just keep a thread that loops around sending messages through this WebSocket whenever new messages are available. Okay, so we know from the previous videos that you can send messages on a channel in a blocking fashion, like we did in the concurrency video. Again, please go ahead and watch that if you haven't watched it yet. But using that same logic, we can actually try to read a message for the subscriber and then send it on the WebSocket when a message appears. Let's go ahead and see if we can implement that. So we use the select statement again, like we did in the previous concurrency video. And then we say, let's see if we can get a message from the messages channel that this subscriber has, right? So here we go. In this case, we've got a message. So now we need to send that message. The way we send messages is we create a context and we'll say we'll give it a timeout, right? Because something might have happened. I mean, may have timed down in the meantime. And then just like any context handling, we defer cancel, right? And then we get the c.write. So now we're calling .write on the WebSocket connection. And we say that this is going to be a message text. And then we pass it the message that was read. So let's just go through this again. I know there's a lot going on here. But see what we're saying is we're going to keep looping through this loop, right? Inside this thread that we're spinning up for the subscriber. Within that thread, we're going to block on the subscriber channel. So the channel that we traded for this particular subscriber that we are handling here, right? We traded the subscriber, we traded the channel. Cool. And within that channel, we are going to try to read a message. And every time we read a message, we are going to try to write that message over the WebSocket, right? And then let's just handle the error case. So we have something goes wrong, we'll return error. Very good. And I think that's all we need to do. Oh, we can have another case, actually, which is the case done. Let me just format this. Because context done is another case, in which case we can just return context.error. This is a Go convention that when you call done on a context, it actually throws an error, even if it's not a real error, that it will throw an error that you can assert. Let me know in the comments if you want me to make a more detailed video on how contexts work in Go, because I realize that the one might be familiar with it. Okay, so now we have a handler for handling subscriptions. Very good. Let me just fix this. So you can see the only thing I left out is the add subscriber function. Now the add subscriber, the reason I left this out is if you think about what we want to do when we add a subscriber is we have this map of pointer to subscriber and an anonymous struct. So what we want to do, we just want to add something to that map. However, bear in mind that we are in a concurrent situation here, in that we have a web server that's spinning up these threads every time these requests come in. And so a map, again, if you've watched my concurrency video, you'll know that a map is not concurrent safe or thread safe by default. And so what we need to do is we need to protect this map behind a concurrency mutex or a resource. And again, I know I've said it a lot of times, but if you haven't watched my videos, on concurrency, now would be a good time to go ahead and do it. Because what we're going to do is we are going to introduce a subscriber's mutex, which attacks the subscriber's map from concurrent reads and writes happening, which means that when it comes time to implement add subscriber, which is also going to be a server method, or when say add subscriber, we've already got some context. I already got the context. We don't have the context here. We're just going to add subscriber itself. So we're going to take a pointer to the subscriber. And now Copilot's already beat us to it. But essentially what we want to do is we are going to, and this is absolutely correct, but I actually prefer doing it explicitly when you are dealing with resource locking. So what we're doing is we're saying, we are obtaining the new text lock so that we can make changes to this map in a thread safe way. And then we're storing our subscriber, and then we're calling unlock to say we're done. Someone else can now go ahead and mess with this map. And then we can just say we added a subscriber. Okay. And let's just print out subscribers. That's fine. So that's a whole lot of code that we've added here. And we're not really using it yet. So how do we use this now? We've got this web server that's serving the static HTML. Very good. And how do we add another route to it? Well, it's quite simple because we have the mock server that we created earlier, right? So in our new server function, let's just go up and find it. We can now just add another path, and we'll call this -WS for WebSocket. And we'll say when someone tries to connect to the WebSocket path, come on, Copilots. Yeah, and I think I'm going to go ahead and disable Copilots after this because it's very, very annoying, actually, the way it generates all this stuff. And so now we should be able to pass this. Let's just see what's going on here. Sorry. We need to take a pointer to a request. Yes. And then here, pass it, a reference to it. No? What's going on here? So we've got a writer, which is right, and we've got a request. So why is it not happy? Let's subscribe. Subscribe also needs to take a pointer. Sorry about that. So now I think it's happy, generally anyway. And so now we said there's actually another path on our web server that needs to be handled, which is the /WS, which takes a subscription handler. Okay. So what do we do now? First, let's call go.tidy to download the WebSocket package that we need. Very good. And now if we run our server again, it's running, but I think you'll find that nothing's really happening. If we refresh here, it's still the same, right? Nothing's changed. So we'll keep the server running, but this is because we now obviously need to implement our WebSocket handling. So how do we do that? Well, HTMX has a lot of different ways of actually doing WebSocket connections, but the easiest way is simply by wrapping some data that you're or some part of the DOM that you're interested in being WebSocket enabled inside a div, like so. Let's go ahead and do that. And this div, as you can see, has a tag that says this div should trigger the HTMX extension WebSockets, and it should attempt to connect to this endpoint using a WebSocket. Okay, so let's try that. I've saved that file. Now we can go ahead and refresh the page. So we don't see anything in the front end. Do we see anything inside our terminal? Of course, we're still printing stuff out. What we should have seen is this line here, add a subscriber. So we can actually see that we got a new WebSocket subscriber that came in. So now it's time for the interesting part. Let's try actually writing some data to the WebSocket. So we've got this silly thing still running every 3 seconds and printing stuff out. Let's change that, right? So instead of printing things out to console, we actually want to send data to our WebSocket subscribers. So let's go ahead and implement a simple function on our server. And you might see where I'm kind of going with this. And we can call it broadcast. And let's see what Copilot came up with. Yeah, it's pretty good. It's pretty good, except I don't actually want to do this. What I want to do is I want to go through the subscribers. And then I just want to send the message on, if I go subscriber, exactly, subscriber log messages, I want to send the message on that channel, right? So all we're doing is we're acquiring the subscriber log because we're changing the subscriber thing. And then we are we're sending the message to be sent that we're passing into broadcast onto the channel. So the result of this is that all our subscribers will have the message that's been broadcast sent onto their channel. So let's try this out. So we can pass in, actually, if we just change this, the order of this, we can say that this function takes a parameter s, which is the server to send on. So we'll pass that in down here. And let's just go ahead and see what happens when we broadcast some of these messages. So rather than printing them out, we are now going to call s.broadcast, and we're going to broadcast these different things. So system section, disk section, and CPU section. Let's see if this does anything. So got an error. Oh, that's just the OSP being silly. So let's run this again. Starting system monitor. So now we can refresh the page. And again, we're not seeing anything. Why are we not seeing anything? The reason is, which I told you at the start of the video, is that in order for this to work, HTMX needs to send raw HTML. We're not sending raw HTML. We are simply sending the things that we printed to console earlier. We're just sending those on the socket. What we need to do is we need to send some proper raw HTML. So let's just quickly go ahead and build this before we end this video. So we'll say HTML, and then we'll create some tags. And the way it works is HTMX allows you to specify where the different things go. So for example, we can say we want a div that swaps the inner HTML of a target. And that target could be update timestamp, for example. Okay. And what goes in update timestamp? Well, let's create the time.now, for example. So we can say timestamp equals time.now. Yeah, we can format it, that's fine. And so what we're going to do here is we're going to pass in timestamp. And rather than broadcasting our sections here, we're just going to broadcast this. Okay? Let's just comment these out for now. So, still happy about that. No worries. So if we go ahead and run this now, and we refresh the page, let's see if anything happens. Boom! Suddenly, we have a timestamp coming in that's updating every 3 seconds. So what's actually happening here, right? Let's just walk through this again, because I realize we've done a lot in a short period of time. What's actually happening is we have the WebSocket that we are connecting to from our front-end application. That makes us add the WebSocket as a subscriber. If we go back here, you can see add subscriber. And our server is now running with the subscribers in place. This Go routine now runs every 3 seconds. And what it does is it populates some HTML. It uses HTMX to say, when you receive this HTML, this is what you need to do. In our case, swap the inner HTML about the timestamp with this new HTML. And then we call broadcast, sending this message on the WebSocket, which in turn calls HTMX to update it on the page. And all that is happening in real time. We can refresh the page, and depending on where we are on the time, it will happen again, right? The server is constantly pushing out updates. And so now, all we have to do, final thing, is we can add some more divs for us to change here. So let's go ahead and update, for example, the, what do we call it? I think we call it system data. And then we can reintroduce that up here. We'll call this system data, and we'll put system data in there. Okay. Let's run that again. And suddenly we have system data coming in. And then all we need to do now is we can do the same for our other two, right? We'll uncommon these guys again. And we'll add a disk section, and we'll add a CPU section. And again, here we're just in HTML land, right? So you could do anything here. You could add a thing saying CPU, for example. And bear in mind, there are templating languages that will make this easier. Here we're writing kind of raw HTML in strings. This becomes quite unmaintainable if you build a big project this way. But we're just kind of demonstrating how this works. Just on the monitor, we're not refreshing the page or anything, because we should have maintained the WebSocket connection. Maybe we didn't. I know what happened. We got ahead of ourselves and didn't change these. All right. So let's go ahead and run up again. And now, there we go. Suddenly, we have more and more data coming in. You can see it's changing every 3 seconds. You can see that the used memory changing. And now, all you need to do, if you want to, is you can go and style this, add whatever data you want to it, and have it be your very own hardware monitor for you to play with. I'm going to stop the video there because we've been going for quite a while. I realize there's a lot to look at here, so please have a look at the source code, which will be linked in the pinned comment below, and to know that HTMX and WebSockets are a really cool way to build these modern reactive front-end applications using technologies that are really quite difficult to use in the past, but now become really easy with these concepts. But thank you so much for watching, and I will catch you in the next one. Bye-bye.